Alrighty then. Now we're going to start doing routing in a network. How does a packet get from point A to point B? Well, we're going to discuss all these things in a little bit, but first, let's discuss the process that it takes. And now, in order to do that, all right, one of the things that's going to come into play is administrative distance, but let's talk about exactly what it takes, right? Which is this right here. All right, so we got this lab, and this is the lab that we're going to be working with throughout the routing, throughout this section, okay? So let's say we have this web server over here, and that's in the 10.0 network, and we have this DHCP server over here. It's in the 30. network. And we just want to verify connectivity, so we just ping, okay? It really doesn't matter as far as the port number is concerned, because in order to route a packet, you need what? What do you need? You need a source and destination MAC address, a source and destination IP address, and obviously a port number, right? Which creates that socket. All right, so here, the very first time we ping, since it's Ethernet and we're in IP version 4, we know we have the ARP issue. So the web server throws up an ARP request to its gateway, and it says, hey, I need your MAC address. I know your IP address, I know my IP address, and I know my MAC address. But in order for me to send packets up to you, I need to know your layer 2 address, your MAC address. So then the router says, oh, okay, wait a minute. That's me. Let me send down a reply, and I'm going to give you my MAC address. Once that's complete, now it's got the local layer 2 addressing, and it has the layer 3 addressing, and it knows the port number. It's going to go up to that particular router. That router, once it receives that information, is going to say, hey, listen, I am a router. I only look at layer 3 information. So I'm going to just trash the layer 2 information. All I care about is layer 3. Let me take a look at my routing table and let me see where you're going. Oh, I see that you're going to the 3.0 network. Not a problem. I know I need to send you out that interface in order for me to get to where you need to go. So he sends you out this serial connection where there is no ARP, okay? It goes out to the next router, and then that router says, let me get this layer 3 information. Oh, I see you're going to, I said 3, I mean 30. The 30.0 network, not a problem. I need to send you out that interface. So then he goes ahead, after he checks his routing table, sends it off to the next router, and then the routing table, that router goes, all right, let me see where, okay, you're coming from this source, and you want to go to this destination. Yes, I need to send you down the S00. But now we're getting into layer 2 stuff, right? So when he sends that ARP request to that server, it says, well, hey, I know my MAC address, I know my IP address, I know the IP address I want to go to, but I don't know your MAC address. So that server needs to say, well, here you go, here's my MAC address. He gets it, completes it, and then it gets sent down. That is the process, right? And that only happens once. That's why we have an ARP cache. Because once you go through it once, there is no more ARP. There's still broadcast, but there's no ARP broadcast, okay? And then the reverse goes, and then it replies, obviously, because it really knows all the information, and then it goes around. All right, and the same process happens. All right, now he knows when he does the reply, he'll get his MAC address. And that's it. But you need those 4 things. I'm repeating this several times so you know that's going to be a question. 4 things. You need source and destination layer 3 addresses, source and destination layer 2 addresses, and a port number. Now the layer 2 addresses will stay within their own segment, layer 2 addresses. So if it's going this way, it'll create an ARP request here, or it will create an ARP request here and an ARP request here. It could be 3 ARP requests. If there's only 2 of these, there'll be an ARP and an ARP. ARP only happens at layer 2 because between serial, if this would have been Ethernet, then that would have been another ARP, but it's not. This is serial. So there is no ARP going on between these 2 routers. Okay? Alrighty then. And if we are simulating, let's say we're doing firm relay, then we will have something called an inverse ARP, which is a mapping of a known IP to a DLCI. That's all it is. All right? But we're not dealing with that right now. This is just a basic process of routing. All right, now that we got that out of the way and we understand, well, I hope we understand, okay? And let's switch back over here. All right. So now that we know how things get across, well, what is an administrative distance? An administrative distance is a given number to the type of routing that you're going to use. And like it says right there, the lower the number, the more believable that route is. So you got to keep that in mind when you decide what type of routing you're going to do. Now, there's default routing, and here's an example of a default route using an exit interface. And this is what you would see when you do the show IP route in your routing table. You will see an S with an asterisk, okay? This is what a default route is. And the purpose, which you'll learn, what a default route is for, so the router, when it receives the packet, it does, even though there's no entry in the routing table, it doesn't drop it. That's the purpose of a default route. Static routing, all right, here's an example of static routing. We have the destination, where we want to go to, the subnet mask of the destination, and the exit interface. Now, here the AD, or the administrative distance, could be 0, 1. If you use the exit interface, it would be 0. If you use an IP address of the next router's hop address, it will be a 1. It will be a 1, okay? Because you're going to the next router's hop address. So then the administrative distance bumps up 1. But it's still lower than anything else you see, because you're going to dynamic routing, RIP 120, EIGRP 90, OSPF 110, internal BGP 200, external BGP or exterior BGP 20. Okay? Still, static routes still beat it. So we will have a lab, do not concern yourself, with static routing, and we're going to combine static routes with default routes, with dynamic routes, and you see how all that's going to work together and how we can use static routes as backup routes. Now, you have to know your network. You need to know the type of equipment you have, what it can hold, how many subnets you have, the design. You have to have already a picture drawn out or in your mind of how things are going to go back and forth and how many devices you have. Because if you do static routing, that's great. Less overhead on the router. No CPU usage, no updates being sent out, more secure. You can control it more, but it's more overhead for you. You can have 10 routers and use static routes, sure. But what if underneath those routers you have 20, 30, 40 different subnets? Oh, that's a totally different story now. Now we got to put those entries. And do we take them out? We got to take out those entries. So it's a lot of manual work. So it's just too much overhead for you, the administrator. So that's where dynamic routing comes in. So we have all these types of routing. Just keep in mind the administrative distance. And even though EIGRP used to be proprietary to Cisco, they're now saying that other devices do support EIGRP, which is a dynamic routing protocol. But I don't think that's made it to the test yet. So if they ask you if it's a proprietary protocol, yes, it is. All right, EIGRP, yes, it is. But in reality, it isn't anymore. Supposedly, all right, do your research. Supposedly, EIGRP is now it can go across vendors. But I think for certification purposes, they're leaving it as a proprietary, especially for the CCNA. All right, so this is a process of routing. This is what we need to consider, administrative distances and the type of routing that we're going to do. Now, before I let you go, the default routing, and we'll talk about it when we actually do it, you only do it on the edge routers. And the reason is, again, not to drop packets, okay? I think I said that, but I just wanted to reiterate that. All right, but we'll talk about it again when we do labs. But this is it. This is the types of routing and how routing works. I'll see you in the next one. All right, here we are in our first lab. This is the lab that we're going to be working with. You can see it's already green lights because I've already configured a bunch of stuff. All right, so I can show you. All right, but what we're going to do is we're going to do default routes. Default routes. And we'll actually take a look and see how that works without default routes, just connected routes, and then default routes. Because remember, once you bring up a router, it's going to know about its directly connected neighbors. But it's not going to know, like say like this router right here. All right, it's not going to know about that network or this network right here. It has no idea about those networks. So what happens if we would ping? We're going to find that out. All right. And what happens when we do actually configure default route? Will I get a different response? We will find that out. All right. So this is the lab that we're going to work with. I'll walk you through it, creating the default routes, and you'll see it'll be very easy to do. I'll see you in the lab. And here we are again inside a lab, but now you can see this lab is different. All right, now we have 3 routers, 3 switches, and you see we have all different types of servers. All right, now we have our basic administration commands, and we'll go into router 1. Let's go ahead and maximize that. And we hit enter, we just type in Cisco. We don't have in the username and password, so we didn't say login local. And this would be, this would be student, S-T-U-D-E-N-T. Okay. Oh, really? All right. Cisco. Oh, C-I-S-C-O. I think I put it in uppercase. No. S-T-U-D-E-N-T. No. Enable. S-T-U-D-E-N-T. There we go. It was case sensitive. No problem. Haha. All right, so here we do a show start. You can see that we have all our administrative commands that we've done in the previous, the domain and all that good stuff. And we have our interfaces. One of the things that you do when you get into there, before we start doing any kind of routing whatsoever, make sure you do the show IP in brief command, and you want to make sure that your interfaces are up. As you can see, ours are. Now, we're talking about default routing. Now, default routing can only take place in what's called stub routers or edge routers, because default routing is only one way in and one way out. It can't have 2 directions. It can only have 1 direction. Now, the purpose of the default router, or the static default route that we're going to use, is so the router does not drop any packets. So when the router looks at its routing table, again, we'll take a look at router 1. How do we look at a routing table? Show IP route. All right, you can see that there's 2 connected networks it knows about. 2 connected networks, the 10.1.14 and the 10.0 network. It doesn't know about any other network. So that means there's no way you can get to another segment, another network that you want, the remote network that you want to get to. But let's see what happens. Let's see what happens. And let's investigate as we go. All right, and let's go to the desktop. No, not there. Close that. And there we go. All right, so we're going to ping 192.168.20.1, and it says destination host unreachable. The router actually dropped the packet. Okay, because it says, hey, I don't have an entry in my routing table for this particular network because, you know, it's just not there. So I have no idea how to get to it. I'm like, all right. So we don't want to do a routing protocol yet. We said, well, you know, let's do a default route. Let's do a default route, a static default route. So there's no overhead on the router. It's not a big deal. It's not a huge network. There's not that many subnets. Let's go ahead and do a default route. So the way you do that is static, and I emphasize that. All right, config T, IP route 0.000, 0.000, oops, too many zeros, and S0/0/0. Now you could put an interface, an exit interface, or you could put the next hop address, meaning the other routers that is connected to the 10.1.1.6. You could have put there if you wanted to. But the difference is that, hey, it's going to look like a connected route. So it's a better way of doing it, according to Cisco, using the exit interface. So let's go ahead and copy that, and we'll do it like you would in the test. We'll exit one time, and we'll do a copy, run, start. Do I want to copy it to that file name? Yes, I do. And if we do a show IP route again, now we see an S with an asterisk. And remember, you have these little code things up here. The asterisk means it's a candidate default, and the S means that it is a static. Where's the S? Somewhere in here. I can't see. Here it is. S, static route. No, that's per user static route. Well, if you find the S, there it is. Static. All right. It's a static default route. That's what this is. So let's see what happens when we try and ping again. All right. Let's go ahead and open that up. I'm just going to up arrow. I'm going to hit enter a couple times. And let's up arrow to the same address. Now this time, see how it's thinking about it? It didn't automatically came back and said, hey, I can't reach it. Now it's giving us a request timeout. What that means is they got to the destination, not a problem. But as we explained earlier, as you know, the routing process, the packet made it to the destination, but when he tried to reply back, this router said, hey, I have no idea how to do that. There's no, I don't know where that particular actual network is. So this is why you're getting a request timeout. I'm like, okay. So what we need to do is static routes, but we're not going to do that yet. We're not going to do that yet. So what we're going to do, we're going to set it up so we learn when we get to that particular lecture, which is the next lecture, how to do that. So the same thing is going to occur here. All right, this router, if you do a show IP route, it only knows about its connected neighbors. So what we're going to do is we're going to go to global, we're going to do IP route, and then we're going to do 0.00, 0.00, and then the exit interface, which is S0/0/1. Okay, and we do a IPM. I'm so used to doing it. So let's go back, copy, run, start. Enter, enter, show IP route. And you can see you have your static default route. Now remember, the purpose of this static default route that we created, and it shows you that it's connected because you're using the exit interface, is so the router does not drop the packets. It just says, hey, listen, match any IP address with whatever mask. That's what the zeros mean. Match exactly. Match these two things, whoever they are, and just send it out this interface. So it'll go to the next router and let the next router make a decision for me. That is what the static route or the default static route is for. Okay? So the router does not drop any packets. Why do I keep repeating that? There has to be a reason. All right? You know me, there's a method to my madness. So the purpose again for default static routes is so that the router does not drop anything. It will match everything that comes through it because it has the zeros. Zeros means match exactly. So it's going to match exactly whatever IP address. It's going to match exactly whatever subnet mask and then send it out whichever exit interface you chose. Now remember, it can only go in one direction. So if let's say over here, and let's just pick a cloud just to pick one, and you send it out that interface, well now you're saying, okay, this is the way to go if you want to go to whatever network. So you're either sending it to the internet or an external network. That's not what you want to do, maybe. If that is what you want to do, then okay. Be very careful when doing static routes, which you will learn next, or default routes, because you could create a routing loop. Because if you send it to one, let's say I send it to that cloud, but that cloud has instructions to not allow anything to go out that way, it'll send it back to the other one, and you just keep going back and forth, back and forth. So be very careful, or it might not even work. So be careful, know your network. I mean, that goes without saying. So you know exactly which exit interface or next hop address, because you could have used the IP address right here of this particular interface as your next hop address, which is 10.1.1.6. You could have used that, and then it will go that way, but then it won't show up as a connected route. Not that it really matters. Now, default routes or static default routes can be used in combination with other static routes or even dynamic routing protocols. It will always exist on there. They will not go away. Unlike static routes, which we'll talk in a second, because of administrative distance. I won't get into that in the next lecture. But right now, we have prepared, let me get rid of this cloud. We have prepared our lab. All the administrative commands are there. We have our static default routes on our stub routers, meaning there's only one way in and one way out of the network. Now, what we need to do is configure this router, but with this router, we're going to configure static routes. We're actually going to tell it, hey, I want to go to these networks, and this is the direction that you need to go in order to get to that network. All right. All right, so I'll see everybody outside the lab. Was that easy or what? You saw the difference. The first ping, what was it? It was unreachable because it only knew the connected routes. So it said, well, I have no idea where this destination network is. Drop it. So once we configure the default route, what do we get? A request timeout. Meaning the packet got there, but it didn't know its way back because this router says, I have no idea where that's at. I don't have an entry for that. And remember, default routes can only be on the edge routers or stub routers, one way in, one way out. It can only go in one direction. So you can't use a default route here. All right, so we're going to fix that in our next lab, which is going to be static routing. All right, but now you see. Now you see that they actually routed all the way to here, but it just couldn't find its way back because that's what a request timeout means. It means it got there, it just got lost. They didn't know how to get back because they didn't know how to route it back. But we're going to fix that issue in our next lab. See you then. All right, here we are, same lab. We have our default routes on either side. All right, and now we're going to do static routes on this router right here. So when we do the static routes, we need to tell the router, hey, what routes don't you know about? Well, this router has no clue about that network right there, and it has no clue about that network right there. So we're going to tell them, but we're going to tell them in a special way. We're going to increase the administrative distance. Why? Because the administrative distance, we just talked about that. The administrative distance of a static route is 0 or 1, depending if you use the exit interface or the next router's hop address. We're going to use the exit interface. That's what's recommended by Cisco. So we're going to use the exit interface. But after that, we're going to put a higher number. We're probably going to put 150. That's what I always put. All right, because RIP, which is our first dynamic routing protocol, is 120. So you're going to see what happens there. But right now, we still can't get anywhere because this router has no idea how to get back to the outer network. So remember, it's your neighboring routers, all right, that update each other. All right, so this router has no clue. And they can't update each other because they don't have any routing protocol to snitch themselves out. All right, so let's get inside the lab and let's do some static routing. All right, welcome back, everyone. As you can see, we're in the same lab as we were before, but this time we're going to configure the router in the middle, router 2. All right, because the other two routers, these stub routers, we already put in default routes there. And remember, when we pinged, we first got an unreachable because that router has said, hey, I don't have an entry in my routing table for this network. So when we gave it that default route, or that static default route, it said, hey, I'm just going to send you to the other router. Maybe that router knows about it. And it does. So when I send it to where it needed to go, but when the reply came back, remember, because pinging is a request and reply, right? So when it replied, it's the router, the second router said, I have no idea where that network is at. So it dropped the packet. But you can't put a default static route on the middle router because remember I said that it was only one direction. So here we're going to have to configure static routes. Now with static routes, you do have to be careful with administrative distances. By default, they either use a 0 or a 1. Now, if you put the exit interface, it will be 0. It will show you as directly connected. If you use the next router's hop address, it'll show as 1. So it's still lower, very low number. The lower the number, the more believable the route. So if we were to configure RIP, which is one of our first routing protocols we'll configure, it will never make it to the routing table because the administrative distance of RIP is 90. So it's going to believe more the static route than it would the routing protocol. So what we're going to do is we're going to actually create static routes, but we're going to add an administrative distance that's higher than RIP, which is not 90. It's 120. I'm sorry. It's 120. So we're going to put in 150 as the administrative distance. So let's do that now. Let's go into the middle router. Let's maximize it. We're already inside. That's good. So we're going to do config T, and then I'm going to go IP route. Now you got to tell it about the networks that it doesn't know about. All right. Not like when you do a routing protocol that you advertise your networks. With static routes, you say, hey, I want to go to that network because I don't know about that network. So 192.168.10.0 with a subnet mask of, a subnet mask of 255.255.255.0. And I want to go out my S0/0/1 interface, but I'm going to have an administrative distance of 150. Okay, that way when I do my routing protocol, the routing protocol will take effect because it has 120, but the static routes are still there just in case the routing protocol goes a little insane and you have a backup route. Okay, so let's go ahead and do now for the other network we don't know about, which is the 30 network, 192.168.30.0, 255.255.255.0 out of the S0/0/0 network with a 150 for the administrative distance. We're going to copy that. Now remember, you can't do WR in your certification. You have to go back to privilege mode and do a copy run start. I keep saying this over and over again, but I just want to make sure you do know that, all right? Because I have a very bad habit of just doing WR or Control Z and things like that, which you cannot do in the certification. So now let's take a look at the routing table. I did a Control Z there, show IP route, and you can see now you see S's, right? You have a bunch of C's, that means connected, and you see S's, which is static. So this is an actual static route, which shows that it's directly connected because we're using the exit interface. So we're going to minimize this particular router, and we're going to go back to that PC that couldn't ping before, right? Where you got that destination host unreachable. Then when we got request timeout and all those different things. So let's up arrow. Let's do a 20.254. And now we can get to it. Now we know how to get to it. Let's be bold. And let's see if we can go to 30.254. And we can get to that as well. So, okay, can we reach the actual desktops? All right, well, let's do 30.1. That should be the IP address. Now, obviously, the first one is going to be missed because of Ethernet and ARP, but we should be able to ping, and now we can. So here, we're using a combination of static default routes in our stub routers or edge routers, right? The S with the asterisk that represents the default route. That its sole purpose, and we talked about it, its sole purpose is please do not drop any packet. Just match whatever IP, match whatever mask, and send it to the next router. So that's what it did. And when it got to the next router, which is router 2, let's maximize that, it said, okay, well, I know about the 10, I know about the 30, and I need to send you out these particular interfaces so you can get to where you need to go. So we can use combinations of default routes and static routes together. But what did we do with those static routes? Let's do a show start. That was a little bit special, not so special, but because we are doing routing protocols later. Let's keep going, and here we go. All right, we actually put in a different administrative distance. We put a higher administrative distance than RIP because RIP is 120. So if I wouldn't have put a higher administrative distance here, the static route will always win because it has the lowest administrative distance, and it will take over, and it will always be in the routing table. And maybe that's not what we want. Because in a huge network, to do static routing, and that's the decision you need to make, how many subnets do you have that you're going to create static routes for? If it's more than 10, honestly, call me lazy if you will, but I am not going to sit there and, oh, we have another subnet? Oh, let's add it. And we add that static route. Oh, we took out a subnet. Oh, well, let's take out that static route. So we don't want to do that, where the routing protocol does it for us. All right. So this is what static routing is. It's just telling it, hey, this is where these networks are that you don't know about. You haven't learned about it. So I'm going to tell you about it and how to get there. And by the way, I'm going to put in a higher administrative distance. So if I configure a routing protocol, it will take the routing protocol over the static routes. All right. I'll see everybody outside the lab. All right. Simple, simple, simple. Once we put in the static route of those networks, boom, magically appeared. We can get all the way across, right? I'll try to make a thing with the serial thing. Didn't work out. All right, so static routes, but we did give it an administrative distance of 150 because I'm preparing, right? I'm preparing for the next one because we're going to use a routing protocol next, all right? But I don't want to get rid of my static routes because my static routes, not my default static routes, right? The S with the asterisk. My static routes, just with the S, all right? They're going to be my backup routes. And you'll see it when we get into that lab. But you see now that once we configured it, boom, routing process. Hey, do you know I need to go to this network? Hey, he needs to go to that network. Yeah, sure, just send them down this way. Sure, I'd send you here. So it follows the routing process because now these routing tables are built. It has something to look at and says, oh, yes, I know where you need to go, right? These routers, you're saying, hey, match anything, and send it to the next router. This one is actually looking at his routing table and saying, oh, okay, you want to go to this network? That way. That's all it is. Okay, that's all it is. Very simple. But remember, when we go to a dynamic routing protocol, RIP, all right, remember that we're going to keep these static routes. We're going to keep those default routes, all right? Static default routes. I'm saying that for a reason. And you'll see what's going to happen when we configure RIP. I'll see you there. All right, we come to dynamic routing. Yes, we're going to use RIP, but you got to determine, it's up to you what you want to use. It's up to you, all right? Because there's basically 3 routing protocols that the CCNA has that they've always had. Well, not always, but that RIP, obviously, RIP version 2 is what we're using, and RIP-NG when you get to IPv6. EIGRP, OSPF, and now later on, we're going to do BGP as well. All right. But you need to say, okay, all right, I need to route my packets. How am I going to do this? How am I going to route my packets? Am I going to use RIP? Well, what do I need to take into consideration? 1, the administrative distance. Okay. 2, is it going to cause a lot of overhead? Because RIP, okay, you're talking about now, 15 maximum routers. It sends updates every 90 seconds or 30 seconds. Sorry, 30 seconds by default, but you can change that. All these things can be changed. All right. So it's a lot of overhead. It's a lot of overhead. So small networks, you're saying, okay, I like EIGRP, but am I using the same hardware? All right, is it all Cisco, quote unquote, right? So you can use EIGRP. EIGRP based things is a different algorithm. It doesn't use the Bellman-Ford, it uses the dual. So now we're looking at K values, with bandwidth, delay, reliability, load, MTU, all that stuff. So it pays attention. Not that it really matters in a topology like this, but obviously this is a lab. Or am I going to use OSPF? Oh, but OSPF, my God, a lot of overhead. It uses the shortest path first algorithm, right? It uses shortest path first calculation. It has the Dijkstra algorithm. Don't worry about the physics. All right, that's the algorithm that it uses. But it has a lot of steps to calculate the cost, right? Because OSPF has cost, EIGRP has metrics, and RIP has hop counts. RIP doesn't care about bandwidth or anything else. It just says, okay, which is the shortest way to get to where I need to go? How many hops do I need to take? Oh, just one? I'm going that way. Even if it's a dial-up, doesn't matter. If it's only one hop, it's going to go that way. You can have OC51 lines going all the way around, but there's 3 or 4 hops. RIP is going to say, one hop, I'm going this way. So that's one of the things you need to pay attention to. So what we're going to do in our first dynamic routing lab is we're going to configure RIP, right? RIP version 2. And we're going to configure on each and every router, and we're going to see how simple that is. But we'll explain because RIP is a class-full routing protocol, and you'll understand what I mean when we get to the lab. I'll see you then. All right. Passive interface. How to use it. All right. There are many ways to use the passive interface, but we're doing it with RIP. All right. You configure it inside RIP. And here's a command right here. Passive interface, and then whatever interface you want to make passive. It's completely up to you. But what does it do? What does the passive interface actually do? It tells it, hey, I'm not going to send you, my neighbor, or whoever was pointing out to the, to an exterior network, whatever the case may be. All right. It's not going to send out any updates. It'll receive updates, but it won't send updates. Now, when using the passive interface command, as it says there, okay, you can go ahead and do it on a per interface basis. You can say passive inside routing protocol, passive interface, this interface, passive interface, this interface, passive interface, this interface. You can do it per interface, it's up to you. Or you can use the passive interface default, which turns all your interfaces into passive interfaces, meaning they won't send anything out. And then you got to go to each, well, not to each and every one. You got to go in there and say, no passive interface, this interface. No passive interface, this interface. It all depends on how you want to do it. All right. But what we're going to do is this one. We're just going to go ahead and go to a router and go ahead and say, hey, passive interface. And then we'll see what happens if they're getting updates or not. All right. So I'll see you in the next one. Alrighty then. Now we're here in our lab. We've talked about passive interface. Now we're going to actually do it. All right. As usual, we'll verify to make sure we're getting updates. And then we're going to go ahead and do our passive interface. And we see, we'll do it on this router right here. And we'll see what happens. I'll see you inside the lab. All right. Welcome back, everyone. Same routing lab, nothing different. We have our routing protocols in place, our static routes as backup routes in case something happens. Now, we've talked about already in the previous lecture about what a passive interface command is. With RIP, what this does, you do it within the routing protocol, and you tell it, hey, listen, I don't want to send out any updates out of this particular interface. Now, obviously, you would do that if you're going out to the internet, out to a remote network, or just to a network you don't want to send these particular updates to. All right. But the goal of the lab is to show you how this works, okay, and how you will configure it. All right. So we'll do it very simple, very easy. All right. As you can see, let's go to router 2, and let's do a show IP route again, just to make sure that that is the current routing table. All right, and it is. And you can see we're getting updates from the 10 network, okay, via that interface, which is router 1 on my interface for router 2, right? So we are getting updates through RIP. All right, so we're going to stop that. We're going to stop that using the passive interface command. All right, so we'll enter a couple times there. Config T, router RIP, ver2, and then in here you do passive interface, and then the interface you want to put it. In this case, it's going to be a serial 0/0/0, right? That's my exit interface. Okay, what happened? Okay. That's the interface that all updates are going out by. Now, I'm not going to wait, because if I were to go right now to router 2, the routing table will look the same, because we have to wait for those 30 seconds, right? Because every 30 seconds, RIP updates. Show IP route. I don't feel like waiting 30 seconds. So if you look at it, it looks like, see, it says R 192.168.10.0. So what I'm going to do is, I'm going to make sure this is copied, and I'm going to reload the router, which will force everything. Obviously, you're not going to do this in a production network. All right. As you configure, design it properly. That way you know, hey, I don't want to send any advertisements out this interface. I'll receive advertisements, but I won't send any. Okay. And there's a little trick in the packet tracer, because they've asked me this question before. All right, where, hey, I can't get inside my my router. Let's bring this down here. Okay, you can go to the config tab, click on any one of the interfaces. It'll go ahead and let you in the router. All right, and then just go back to the CLI. Go back to the CLI, and now you're inside the interface. All right, so no big deal. So let's exit and let's see what happened to our routing table, right? Control Z, show IP route. Look, that R that was there before now changed to an S. Because I'm not sending any updates through RIP. Because I'm saying, hey, don't send any updates. Do not send any updates out this particular interface. So I'm not. But I have a static route in between as a backup. So that's why you see that S there. So the static route took effect. I still have connectivity. But that's what a passive interface command does. It will stop sending updates. Now, will it receive updates? Let's see. Let's go to our router 1. Let's go to our routing table, show IP route. And I'm still getting my routing updates from the 20 network. I am receiving updates, but I am not sending updates. That's the whole point of the passive interface. Now, obviously, router 2 can still get to my network because I have static routes as a backup. Okay, so again, it's all in the design. It's all in the design. But you see how that R that we had there before changed to an S because RIP is now not sending updates. Now we're relying on the static route to get us where we need to go. And if we ping 192.168.10.1, let's be bold and let's go all the way. And we can get to it. Now, obviously, that will be defeating the purpose, right? Because we really don't want to send out the updates. We don't want to have a backup static route to, hey, send that anyway. But the purpose of what the lab is for, the purpose is to show you how to configure a passive interface, what a passive interface does, which will stop sending, but it will keep receiving. And normally you're going to do this to an exit interface where it's going out to an exterior network, an external network, that you don't want to send your updates of your particular network to somewhere else that you don't want to. That's what the passive interface command using a particular interface does. I'll see everybody outside the lab. Now that was pretty simple, pretty cool too, because you see we had static routes, so it will still communicate. But you saw that in router 2, from getting a RIP update from the 10 network, the static route said, hey, I'm not getting any RIP updates, so I'm going to be now in the routing table, and I'll take you to that particular network. See how good static routes is? But that's what passive interface does. We said, hey, passive interface within the RIP version 2, passive interface S000. Do not send any updates to the neighboring router. So he's not getting any updates. Okay? So when it goes into his router, I say, I'm not getting up. He can receive updates from him, but he's not going to send them any updates. So now the static route took over. Cool. So RIP went crazy, and for all intents and purposes, but we still have communication. But in reality, remember, if you're doing passive interfaces, usually it's going out to a remote network. It's going out to a remote network that you don't want to send, like the internet. You don't want to send out your routing table, your private network out to the internet. So definitely passive interface will be helpful at that point. And that sounds like a test question to me. I'll see you in the next one. All right, we've done quite a couple things using RIP. Now we're going to use default routes using RIP. All right, and that's why I kept saying earlier, static default, static default, static default. Because now we're going to do a default route, but it's going to be a RIP default route. What is the purpose of using this? Okay, that way, usually you use a default route with a routing protocol. If you have just that one router that's facing out to the internet, you have all the other routers behind it, you tell it, hey, listen, let's create this default route like you normally would, IP route, the next router's hop address. Oh, I'm sorry, 000, the next router's hop address. All right. And then you go into the routing protocol and you say default route originate. All right. Default route originate. And then that routing protocol will tell all the other routers, hey, listen, if you want to go to the internet, this is the way to go. And they'll know how to get to where they need to go. That's the whole purpose of a routing, using a router for default routes, because it goes out on the updates. So all the other routers get it as well. And it will look, instead of an S, since we're using RIP, instead of an S with an asterisk, it'll look like an R with an asterisk. Okay? So that's what we're going to do next in our next lab. All right? So I'll see you there. All right, we've talked about now from our previous lecture the default routes using a routing protocol. All right, so the lab changed a little bit. I had to pretend that we had an actual internet router. So I put another router out there. I went ahead and gave it a network 1.1.1.1. There's the 2.2.2. Okay, I had to include RIP because there's no real routing going on, right? It's not an internet router. So they already know about the networks. There is connectivity already. But the whole point of the lab is to show you how to do the default information originate command in this particular router, because this is the router you would do it in. All right, because this is the one facing the internet. You're going to tell all these other routers, hey, this is the way to go using the routing protocol. This is the way to go if you want to get to the internet using a default route. Okay, using a default route together with the routing protocol. Let's get inside the lab and get it done. All right, welcome back, everyone. You can see the lab looks a little bit different. We're going to talk about now, or we've talked about it already, we're actually going to do it, is the default information originate. What that does is we're creating a static route through RIP to update all the routers saying, hey, if you want to go to that internet server, you want to go to that internet router, well, this is the way to go. And you advertise that through RIP. So instead of getting a default static route, now you have a default RIP route. Okay, so let's go ahead and do this. All right, let's get everything out of my way here. And you would do it actually in the router, like I said. That's the edge, the one that's pointing to the internet. That's why I got my little public IP address there, right? Now, obviously, this is a lab. There's certain things you're going to do because your provider's not going to share its routing table with you. So in order for me to make this work, I have to configure RIP here, right? Add the network to it that I'm connected to that way too. But you will see that way we have connectivity. So as it is, we have connectivity now, but I want you to see how you get that R with the asterisk, all right? That's the goal of the lab. All right, because you can see that I'm already connected to that. All right, so what we're going to do is and I took out the default static route because we're going to do an IP route like we did before, IP route 000, right? 000. This time we're going to use the next hop address of 1.1.1.2 because that is the internet router. And I'm going to hit enter. The difference that makes it a RIP route is I'm going to go into RIP itself, router RIP, version 2. Make sure I'm in there. And then I'm going to go default information originate. Okay. And what's going to happen once you do that, it's going to update all the other routers with an R and an asterisk. Swipe your route. All right. You see that? It shows like that's a static route, whatever. But you can see that's the next router's hop address. If I were to go now to router 2, let's maximize it and you can see the routing table from before. This is what it was. All right, you can see that I do have connectivity already because I have that. All right, but I have no choice. This is not a real ISP. So show IP route. Now we're getting, hey, RIP default route. I mean, updated by router 3 saying, listen, this is how you get to this place. All right, and you get to it via that interface, the 10.1.1.10. All right, and let's see if router 1 is doing it as well. So I mean, you normally do this where there's only one router that's connected out to the internet, and you just want to create one static route. You can do it through your routing protocol, and it will update all the other routers to tell it where to go. And you can see there, you have your RIP with the asterisk, right? So let's say we can ping, and we can 1.1.1.2, right? You can ping the internet router. Now, obviously, in order to make this work, I had to configure RIP on the other router. It's not a real ISP, but just to show you what the default information originate means, because we normally did just a static route. We just pointed the static route to the internet router's interface. But then what made the difference is when you do that default information originate within the RIP routing protocol to update all the routers that, hey, this is a RIP default route. And if you want to get to the internet, this is the way you got to go. And that's what that's telling these routers, okay, with this R and this asterisk, as you can see right there. Okay, you can see the gateway of last resort is set is pointing to the same one, 10.1.1.6, 10.1.1.6. But you're not doing it manually, you're actually doing it through a routing protocol. So if you have just that one router that's connected to the internet, you can do it through your routing protocol. You don't have to do a static default route, but a routing protocol default route. In this case, it would be RIP. All right, very simple to do. Let me go back to router 3 so I can show you the commands again, even though you'll have the handouts for it. All right, all we did, let's go up. All we did is we created a static route like we would, right, with zeros, meaning default, match anything, but send it out to the next router's hop address. Remember, it's very important where we pointed to. This time we're pointing it to the next hop address, which is the internet's router's IP address. And then we go into our routing protocol and we do a default information originate. You can see that I tabbed quite a bit, but the command is right here. And this is what makes that RIP routing or that RIP default route to tell all the other routers, hey, come this way so you can get to the internet. All right, I'll see you guys outside the lab. All right, that wasn't bad. You see, this is the command right here, right? After, obviously, we created our our default route. I'm not going to say static, our default route, but we used the next router's hop address, which was the 1.1.1.2. That's the internet router's interface, okay? And then we came into RIP, as you saw, and we did default information originate, and then all the other routers, when you did a show IP route, or when we did a show IP route, you saw they had the R with the asterisk, all right? That's the whole point of doing that. And you would do it when you have just that single router and you want to tell everybody, hey, this is the way to go to get to the internet. Boom, you have that. Yes, it's going to be a lot better, less updates, less things going on in your network, and everybody's going to know because they're going to be updated through the routing protocol. Simple as that. See you in the next one. All right, we made it to the summary of this particular section. So let's see what we've discussed. We discussed or we explained how routing works, the process of routing, that you need a source and destination layer 2 address, source and destination layer 3 address, you need a port number. Obviously, if you're doing Ethernet, that's only where ARP exists. That's where only ARP exists. All right, and you also need a port number. All right, port number. If it's serial, there is no ARP. If there's serial, there is no ARP. There's a reason why I'm repeating this. Okay, so we talked about the process, the types of routing. We have default routing, static default routing, right? The whole purpose of static default routing is so that the router does not drop the packet if there is no entry in the routing table for it. Okay, it just sends it off to the next router. All right, we have also static routing, which you tell the router, hey, listen, these other networks exist. I know you don't know about it, so I'm going to tell you about it. That's what you do there. Then we have obviously dynamic routing, which is the RIP version 2. We have EIGRP, OSPF. We haven't gotten into those yet, but those are types of routing. All right, those are types of routing. And you need to know your network to make a proper decision, an intelligent decision on which routing protocol, if you choose dynamic routing, which one you're going to use. But as you saw, we use a combination of default routes, static routes, and a dynamic routing protocol. All right. We saw just now how to do a RIP version 2 default route, not a static route, but a RIP version 2 or RIP default route that will update all the other routers. Hey, this is the way to go if you want to get outside the network to the internet, let's say. All right. We did the passive interface, very important. That could be, if I were giving an exam, I will give that in a simulation. All right. That maybe you have an interface that is passive. You want in the routing protocol like we did, and we said, hey, passive interface, the F00, whatever, and then part of your network is not receiving any updates, so they can't get to you. So that causes an issue. So you got to be very careful on where you do these passive interfaces. So we did that as well, and then we talked about administrative distances. Okay, and this is why when we did the static routing, we did 150, because when we replaced when we not replaced, but when we did RIP, what happened? RIP took over. Why? Because RIP has an administrative distance of 120. So what? The lower the number, the more believable the route. All right, so that's what you got to keep in mind. All these administrative distances are tweakable. All right, you can change it, but by default, it is 120. And we were using the exit interface on static routes, that will be 0. So static routes will always win. So that's why we put in there 150. So that's the importance. And these are the things that we need to look at when we're networking. What is it that we're going to use? And all these little features that we see now and we'll see later on in the course that we can use to make our network more efficient. I'll see you in the next one.